All right. Okay, thank you very much. Okay, so starting next term, there will be this new course, as Dan explained, CS489, that will eventually be renamed CS480, but when you look for it, it's CS489. And the title is Introduction to Machine Learning. The course is offered in winter 2017, and the intention is to offer it fairly often in the future, but I do not know the future offerings after that. So at least for now, that's the term that you should look for it. Okay, so winter 2017. So this course will give you an introduction to machine learning. Yeah, let me go to the next slide. Okay, so to give you some examples of what I mean by machine learning, so there's lots of applications. Perhaps the most common one that you deal with every day is whenever you receive some spam emails, then you might have a filter that will help you to essentially just automatically discover which emails are spam versus which ones are legitimate. And this is a good example where what tends to happen is that you receive these emails, and then you might be able to tell the computer which ones are spams or not manually. And these are examples that then can be used by the computer to learn over time what are the patterns that characterize those that are really spams versus legitimate. So machine learning in general is this idea where you can feed the computer with some examples, and then it will learn from that how to generalize, how to categorize things, how to do the right thing in very complex situations. Okay, so that's our first example. There's lots of other examples. So at the moment in the industry, there's lots of enthusiasm for machine learning. That's in part because of some of the breakthroughs in computer vision as well as speech recognition. So for instance, if you have an Apple and then you use Siri or otherwise Cortana with Microsoft, then what's underlying this technology is also machine learning, so deep neural networks that we're going to cover in this course. And the idea is that, again, there's plenty of examples that are fed to a machine, and then the machine learns how to recognize what the person says, and then over time it gets better and better at doing this, and that's how it works. And so in recent years, there's been tremendous progress. We're going to see some of the technology for this. And in several circumstances, now machines are matching human performance. So this is really outstanding. So in any case, I put some examples here. Another one is conversational agents. So some of you might have come across some chatbots on some text messaging platforms. So we're at the point now where you can train a computer to essentially respond to queries, where you can give the computer examples of pairs of messages, and then it will learn to generate new messages based on the pairs that it has received. Okay? So let me just go back one slide. And then so to summarize this, like the main question that we try to address in this course is basically how can we get a computer to adapt by learning new concepts from examples. So that's how I would summarize what the course is about. Now, there's several textbooks we're going to consider. The problem is that there isn't a perfect textbook that contains everything at the right level. So we're going to use several of them. So pattern recognition and machine learning is a good textbook. However, it's a little bit outdated, but it's still very good, so we'll use that one. Deep learning is very new. It reflects some of the recent advances, so we'll make use of that one too. There's another one called A Course in Machine Learning that's also very new and very high level, so it's easy to read. And then there's another one, Machine Learning, a Probabilistic Approach, which is very comprehensive but quite mathematical, so we're going to make use of that one too. So in any case, for this course, we'll simply be picking here and there what is important, and then I'll be providing some slides for, I guess, the main material. Okay. Okay, in terms of the topic, so what exactly are we going to cover in this course? So this course is a course that's focused on algorithms. So you're going to learn how to program a computer essentially to do machine learning. And then depending on the type of applications, we might need to use different models. So in particular, some of the simplest models are known as linear models. So the idea is that the computer learns essentially by mapping some inputs to outputs. And then this might require some linear math and then linear algebra. And then so there's lots of models like linear regression, mixtures of Gaussians, logistic regression, perceptron support vector machines that all rely on this type of linear models. Now, these models are simple, so they're easy to work with, but they're not very comprehensive. They're not the best in general. So what's better is to actually consider nonlinear models, but then they're more difficult to work with. So still, we're going to talk about how we can generalize the linear ones to nonlinear basis functions, also kernel methods, and finally, deep learning. So deep neural networks are an example of nonlinear models, and then we'll talk how some of the recent advances were achieved by using these types of models. In terms of learning, we can do the learning in a supervised or unsupervised fashion. So then we'll have a few lectures as well on unsupervised learning, so how to do clustering. In some cases, the data that we get is really a sequence that might come from a time series, or otherwise a sequence of words. And then so there are algorithms that are specialized for this. We'll talk about, for instance, hidden Markov models and recurrent neural networks. Then after that, we'll see how we can combine several algorithms together. So that's known as ensemble learning. So in general, think of this as like if you and several friends work together on an assignment, then you might be able to get better grades and better results simply because you can pool your expertise. So in the same way, we can get several machine learning techniques to work together and simply be better overall. So that's ensemble learning, and the examples here are bagging and boosting. And finally, in the course, we'll talk about how we can do machine learning on large-scale data. So this will include distributed learning and also stream learning. Okay, so in terms of the logistics for this course, there are some prerequisites. So you should have taken already a course in statistics. The reality is that machine learning is really a form of computational statistics. And so that is essential. If you don't like statistics, I can promise you that by the end of this course, you will actually enjoy statistics. Okay, so it's actually quite fun, and then you get to see how it helps computers to learn. The other important part is to have a good foundation in algorithms. So for this, you need either CS341, CM399, or SC240. In terms of the work, there's going to be some assignments. They will involve some programming as well as some theory. And then one assignment will focus on TensorFlow, which is one framework for deep learning. There's going to be a midterm and a final exam, and then you can also do a project where you can earn some bonus marks. So this is meant to be fun. Based on what you learn in the course, you can pick a topic, go into more depth, and do something that can be either researchy or more applied. It's up to you. And again, it's up to you what you do. Okay, so now, as Dan was explaining earlier, there's several courses. We've got 2 courses in machine learning. There's also an AI course, and perhaps some of you have questions about what's the difference between those courses. So here I try to highlight what are some of the main differences. So again, CS49, the course I'll be teaching, is focused on algorithms. So by the end of this course, you'll know how to program some algorithms or use some of the tools and so on. So it's a fairly applied course. And as a result, the assignments include programming questions. Now, there's also CS45, Statistical and Computational Foundations of Machine Learning, which is more theoretical. So the focus is on learning theory as well as data complexity theory. So in other words, here we look at questions of when is a problem learnable, what does it require in terms of resources, and then also how can we generalize complexity theory to take into account data as well. So there's some really interesting questions here, but it is more theoretical, so there won't be any programming assignments. And I also encourage you to consider this course. Okay, the last one, artificial intelligence. The reality is that machine learning is a special area within artificial intelligence. So there is some machine learning covered also in the AI course, but this course is broader. So this course covers search, knowledge representation, reasoning under uncertainty, and machine learning. The machine learning part is really just a 3-week introduction. And then in that introduction, there are actually topics that are going to be covered in this course, but not the other two. So they include, for instance, reinforcement learning and genetic algorithms. So here, if you take the other two courses, it does not mean that the machine learning course covered in AI is going to be something repeated. It's not the case at all. So you should actually consider the AI course for yet a bit more of machine learning. So in any case, you can take all three courses, and you can take them in any order. So those courses have been designed to be standalone, so you don't have to take one in order to take the other. So again, just take them in any order. Okay, so I'll stop here, and I'll take some questions. All right, well, thank you very much.